Today we're going to take a look at how a turbo works in a truck, the different types of turbos, and the difference between the turbo in your car and the one in a truck. But to understand turbos, you first need to understand the basic workings of a semi-truck engine. The engine starts with the air intake, where the engine draws in air through the filter. This air gets compressed inside the cylinder as the piston moves upward, leading to a substantial increase in temperature and pressure. Once compressed, diesel fuel is injected directly into the highly pressurized air, and unlike gasoline engines, there are no spark plugs. The heat generated during compression is enough to spontaneously ignite the diesel fuel, initiating controlled explosions. The combustion or power stroke forces the piston down the cylinder, converting linear motion into rotational motion. This motion rotates the crankshaft, generating power. After the power stroke, the exhaust valve opens and the piston moves back up, expelling the burnt gases in the exhaust stroke. This is where the turbo comes in. In heavy-duty trucks, a turbocharger is often employed. This device utilizes the exhaust gases to spin a turbine, which in turn forces more air into the combustion chamber. The process of turbocharging enhances power and efficiency by allowing more fuel to be burned. The entire cycle repeats in each cylinder, ensuring continuous and efficient power generation for truck movement. This comprehensive process of air intake, compression, combustion, and exhaust forms the fundamental operation of a semi-truck diesel engine, facilitating the transportation of goods over long distances. But has the turbo always been around? The turbo, commonly known as a turbocharger, was invented by Swiss engineer Alfred Bucci. Alfred Bucci developed the concept of turbocharging in the early 20th century. His work on turbochargers began in the 1910s, and he was granted a patent for his invention in 1905. However, it wasn't until the 1920s and 1930s that turbochargers began to be used in practical applications. The primary motivation behind the development of the turbocharger was to improve the performance of internal combustion engines, particularly those used in aircraft. By compressing the incoming air before it entered the engine's cylinders, the turbocharger allowed more fuel to be burned, resulting in increased power and efficiency. This was particularly beneficial at higher altitudes where air pressure is lower and naturally aspirated engines tend to lose power. During World War II, turbochargers were widely used in military aircraft to enhance their performance at high altitudes. The technology continued to evolve and found applications in other fields, including automotive and industrial engines. In the automotive industry, turbochargers gained popularity in the late 20th century as a means to improve the power and efficiency of smaller engines without sacrificing fuel economy. Turbocharging became a common feature in both gasoline and diesel engines, contributing to the trend of downsizing in the automotive sector. Today, turbochargers are widely used in various applications, including cars, trucks, and industrial machinery. They have become an integral part of engine design, providing a balance between performance and fuel efficiency. The first turbocharged truck was the Mk26, which was introduced in 1951, and by the 1960s, turbochargers became more common in trucks, particularly in Europe and North America. Today, all heavy-duty trucks have turbochargers, as they are essential components in modern trucks and play a crucial role in the trucking industry. Types of turbos. But are all turbos the same, or are there different types? Now let's explore the different types of turbos. Single turbo, twin scroll, variable geometry, and more. All have their unique characteristics. Single turbo, basic type used in small to medium-sized engines. Simple, reliable, and cost-effective. Twin turbo uses two turbos for larger engines, providing more power and torque. Commonly used in V6, V8, or V12 engines. Twin-scroll turbo has two separate scroll chambers for better exhaust gas flow and reduced turbo lag. Generally found in larger engines for improved performance and efficiency. Variable geometry turbo, VGT, adjusts vanes to change the angle of the turbine and compressor wheels. Common in diesel engines and larger engines. Electric turbo uses an electric motor to spin the turbine, eliminating turbo lag. Still in early development stages and not widely available. Each type has its advantages and disadvantages, and the choice depends on factors such as engine size, performance goals, and specific vehicle characteristics. For large-sized trucks, the most common type of turbocharger is the single-stage VGT turbo. These turbochargers are typically simpler, cost-effective, and practical for large displacement engines commonly found in semi-trucks. They provide the necessary boost to enhance power and fuel efficiency in these heavy-duty vehicles. The simplicity and reliability of a single turbo make it a popular choice in the commercial trucking industry. But is it the same turbo as in large trucks? Passenger car turbos are designed for smaller engines, emphasizing efficiency and moderate boost levels, focusing on improving fuel efficiency and performance. They are smaller, less complex, and more cost-effective. On the other hand, semi-truck turbos are larger, built for heavy-duty diesel engines with a focus on sustained power, durability, and handling higher boost levels for long-haul trucking. They come with additional features, larger cooling systems, and are generally more expensive due to the demands of heavy-duty applications. Both serve the common purpose of forced induction, but are tailored to the specific needs of the respective vehicle types. Turbo maintenance. Are there no downsides to a turbo? Maintaining these powerful mechanical components is key to their smooth operation because while they do a lot of good for the engine, they can also fail, and it can be costly. This can happen due to lack of lubrication, foreign object damage, overspeeding, oil contamination, excessive heat, wastegate issues, and boost leaks are common culprits. Regular maintenance, timely oil changes using quality oil, and addressing issues in the air and exhaust system can mitigate risks. If the turbo fails catastrophically, small metal particles or debris from the turbo can enter the engine, causing damage to cylinders, pistons, or other critical parts, and in the worst-case scenario, result in a completely damaged engine. Upgrading the truck turbo. Can a truck's turbo be upgraded? Upgrading a truck's turbo involves adjusting the settings of a turbocharger to optimize its performance, aiming to enhance power output, fuel efficiency, and overall engine efficiency. This process often includes programming the electronic control module, ECM, to modify air-fuel ratios, boost pressure, and other parameters. The results of a truck turbo upgrade can vary but may include increased horsepower and torque, improving acceleration and overall performance. Optimizing the air-fuel mixture and boost pressure can lead to improved fuel efficiency, positively impacting the truck's overall mileage and reducing turbo lag. It's crucial to note that upgrading a truck's turbo should be performed by experienced professionals who understand the specific requirements and limitations of heavy-duty diesel engines. Additionally, upgrades should comply with local regulations to ensure environmental and legal compliance. Regular monitoring, adherence to manufacturer guidelines, and thorough testing are essential to achieve the desired results without compromising engine reliability. And there you have it, a deep dive into the world of turbochargers and how they work. We hope you learned something new and found it interesting. Don't forget to hit the like button, subscribe for more in-depth content, and let us know in the comments what you want us to explore next. Until then.